Earlier in this video course, when I was describing the use of primitive variables, I described the process of conversion as either upward or downward. I described the conversion of an integer, say, to a float or a double as an upward conversion, and said that this sort of conversion is implicit, automatic, and safe. But if you try to go in the other direction, converting downward, where you take a very specific value and try to squeeze it into a less specific value, that sort of conversion can lose data, and so you have to be explicit in your syntax. The same thing is true of complex objects that have an inheritance relationship. When you use an object that's a subclass and you treat it as its superclass, we don't call that converting, we call it casting, but we still use the same directions. The specific version being used as the more general version is called upward casting, and taking an object that's been seen as the superclass and casting it downward to the specific object is called downcasting. And just as with primitive variables, you have to be specific. Let's take an example. I'm working in a version of my application that's called casting objects. In this version of the application, I removed a little bit of code, but I still have a declaration of an olive variable, and then I'm instantiating that variable 3 times, twice as a Kalamata and once as a Ligurian. I'm then adding those objects to an array list that explicitly is declared as only containing instances of the olive class. I'm allowed to pass in the subclass because that's an upward conversion, and it's implicit and it's safe. But now I'll show you what happens when you try to recast downward. I'll go down to the bottom of the code, and I'm going to get a reference to the first item in that array list. I know that it's an instance of the Kalamata class, because that's how I declared it up here. So I'll start off below all the other code and put in a data type of Kalamata. And I'll name the variable olive1. And then I'll get a reference to that object using the syntax olives.get, and I'll pass in a value of 0 for the first item in the array list. Now when I save my changes and build the project, I get this. Type mismatch cannot convert from olive to Kalamata. It's a downward casting that I'm trying to do. Even though I know it's a Kalamata olive, I created it as a Kalamata olive. The compiler and the JVM at this point will think it's simply an olive. So I have to tell the compiler, it's okay, it's a Kalamata olive. Here's how you do it. Place the cursor before the code that's returning the reference, and then declare the native type of the object wrapped in parentheses. Open parentheses, Kalamata, close parentheses. I'm telling the compiler I'm getting the reference to this object, but I want you to treat it as the subclass. I'll save the changes, the error goes away, and all I have left now is a warning saying the value of that variable isn't yet used. So let's go ahead and add a little bit of specific functionality to Kalamata that's not available in all other olives. I'll hold down the Control key on Windows or Command on Mac and click the name of the class, Kalamata, and that takes me to the declaration of the class. I'll add a new public method into the class after the override of the crush method. It'll be a public method that returns a string, and it'll be named getOrigin. And I'll return a value simply of Greece, because that's where Kalamatas come from. I'll save my changes and go back to the main class, and then I'll output the return value from that method using a system.out.println command. And the output will look like this. Olive1 is from, and then I'll append to that the value of olive1.getOrigin. I'll run the application, and there's the result. Olive1 is from Greece. Now, if I didn't have this casting syntax, I wouldn't even be able to compile the application. But if I could, I wouldn't be able to call that getOrigin method. The compiler would say, well, you said that that was an olive, not a Kalamata. And if not a Kalamata, then it doesn't have the getOrigin method. So this is how you cast objects downward, from their general type to their specific type. As you continue using the inheritance model in Java, you'll find that this casting becomes more and more important. The ability to cast upward and downward so that you can either use objects in their general form, that is, as their superclass, or in their specific form, their subclass.